In example 6 here, we are going to show one of our derivative formulas. So we're going to actually show that the derivative of tangent x is secant squared x. So the derivative of tangent x, you can write tangent x, remember, as sine over cosine. So derivative of tangent x is the derivative of sine x over cosine x. And so this is a quotient of functions, so we can use the quotient rule here, which remember is f prime g minus f g prime over g squared. Well, here, let's move it down here. And all over g squared. So our f is going to be sine x, and our g is going to be cosine x. So our f prime and g prime. So f is sine x, derivative of sine x is cosine x. That was our formula earlier in the section. And derivative of cosine x is negative sine x. So they're derivatives of each other, but the cofunction has a negative sign. So f prime then is cosine x times our g, which is also cosine x, minus f, which is sine x, times g prime, which is negative sine x. And then divide by g squared. G is cosine x, so we're dividing by cosine squared. And then cosine times cosine, that's cosine squared. And then we've got minus sine times negative sine. So that double negative is going to give us a positive sine squared x over our cosine squared here. And cosine squared plus sine squared is 1. So this is 1 over cosine squared x. And remember that secant x is 1 over cosine. So 1 over cosine squared is secant squared x. And that's what we wanted right there. So we actually prove that derivative rule using the quotient rule. And we can prove the other derivative rules, again, doing the same thing, taking your trig function and breaking it down to sines and cosines.